Hello, my name is Dominique Brown, and my project is called Predicting DC Residential Housing Prices. The District of Columbia's housing market is notorious for being one of the most expensive and competitive cities in the country to buy. An article from NPR says one of the main reasons is due to the price of land in the district. Understanding the different factors that make a house more marketable can have a personal impact when looking to sell or buy in the area for potential fair asking price. But it also can have a public interest in understanding how neighborhoods and the quality of houses can be invested in without pricing the existing people out. For the literary review, the first article is called Machine Learning Project Predicting Boston Housing Prices with Regression by Victor Roman. And it is about predicting Boston housing prices with the decision tree regressor model. This study used three features: poverty of neighborhood, number of rooms, and pupil to student ratio of the nearest school to run a model to predict housing prices. They used a grid search CV to find the correct parameters for the model. A big takeaway from the author was the limited features to predict the prices. From this project, I will increase the features in determining housing prices in DC. The second article is called Estimating Residential Property Values on the Basis of Clustering and Geostatistics by Beata Kolka, and it looks at clustering housing prices with k-means. The paper develops a two-stage method to predicting housing prices in Poland. First stage takes into account structural features to cluster the properties. This isolates local property markets where properties have similar structural attributes. The second stage estimates the impact of the spatial factor, location, on property value by performing an interpolation for each cluster separately using ordinary Kriging, the Gaussian process regression. This results in property value maps drawn up separately for each of the clusters. This article gives a lot of information on different ways to perform k-means clustering to predict prices. Now, where are the gaps for my project? The DC residential properties has had limited analysis done besides past exploration and limited machine learning models constructed on the dataset. Regression has been done with limited features similar to the first literary review feedback, and that is somewhere this project can improve upon. This project can also compare models, which has not been done limited on this dataset. This project will also include k-means clustering, which has not been done on this dataset and can add more dimension to the overall analysis. Broadly, predicting housing market models have been performed on other markets, but each market is unique and will not necessarily have the same important features. This project will also be able to produce a visual map on different features and prices of the housing market. For the dataset, this dataset I am using is called DC Residential Properties. It is aggregated from 4 different raw datasets. The first dataset is the Census Tracts 2010 data, which includes selected geographic, cartographic, and demographic data. The second dataset is Computer-Assisted Mass Appraisal Residential, which includes attributions on housing characteristics for residential properties. The third dataset is the Computer-Assisted Mass Appraisal Condominium, which includes attributions of housing characteristics for condominium properties. The second and third datasets were created as part of the DC Geographic Information Systems for the DC Office of Chief Technology Officer and participating DC government agencies. The last dataset is the address points that contain location and attributes of address points as of July 2018. This dataset is from the Master Address Repository for the DC Office of the Chief Technology Officer and DC Department of Consumer and Regulatory Affairs. The dataset characteristics are originally 49 columns, 150 rows, and 52.81 megabytes. And here are the dataset sources. The original one is from Kaggle, and then the raw data and how that data was aggregated. So for the hypothesis or research questions for my project will be, which model can predict DC residential housing prices the most accurately? What features are important to predicting DC residential housing prices? And is it really all about location? what are the most expensive locations? For implementation, part 1 will be to create a predictive model for DC residential properties. Linear regression, decision tree model, and random forest regressor model will be all used in this project. And part 2 is location of housing prices. And to do that, I will be using k-means clustering, and I will also create a map to show different levels of housing prices. The next step in my project was to clean the data. I used info, describe, isnl.sum to get an understanding of the columns, the data type, and the missing data. I decided to delete the following columns that are there because they were not relevant for predicting, or they had too much missing data to be relevant. I noticed a common theme that condominium data was missing, so I decided to focus on residential and get rid of the condominium rows, and it probably makes the project more focused. I decided to drop the resident missing data. There is not a lot of missing data left at that point, and mainly it was the target of the model, which is the missing price data, and I did explore other options, and it didn't really affect the final outcome, so I just decided that it was best to delete the missing data. I also changed the square footage from object to float 64, and I used duplicates and found no duplicated data. I then used a box plot to show price, and then used a code to normalize the outliers, which can be showed here, where the housing prices with the outliers, there were some that were in the 2 millions, and it was very, but there were only like a few, so it very much skewed the data, and then this was where housing prices was normalized. And then I added unemployment rate based on the ward, so there's 8 wards. I made the column based on the unemployment rate, and then I used in replacement for the wards, so I did get rid of wards because it would just be circular. And then all the data is, the unemployment data is from January 2019, which lined up with the current data of the prices. I also added dummy variables. I did not add a dummy variable ward, I got rid of that, and then quadrant, AC, and neighborhood. So then I did some exploration, and I did a correlation matrix, and from there I decided to drop stories, building name, and kitchens because they had no significant correlation with the price. And the highest positive correlation to price was the number of bathrooms and the number of fireplaces, and the highest negative correlation is the unemployment rate. Then I did a medium EYB, which is the estimated year built, which is for each ward, which is based on the actual year built and the last year it was remodeled. I decided to choose that and get rid of the date it was remodeled and the original built, because I felt like this was, they all kind of meant the same thing, and this was like an aggregation of the two. And Ward 2 and 3 have the most updated houses, and Ward 4, 5, and 7 are tied for the oldest. Here is the median price of residential houses in each quadrant. The Northwest is by far the highest median price, and the Southeast and Southwest are the lowest median price. And here is the median price of the wards. The most expensive ward is Ward 2, followed by Ward 3, and the least expensive were 7 and 8. The median price of the ward, the median price of the neighborhoods were the highest median price. Neighborhoods were Kalorama and Massachusetts Avenue Heights, and the lowest median price neighborhoods are Berry Farms, Congress Heights, Deanwood, and Fort DuPont Park. And yes. And then for phase 2, for model implementation, part 1 was predicting housing prices. So I did the 3 different models. The first one was linear regression model. The model performance had an R2 score of 0.63, and the decision tree model, R2 score was 0.45, did not perform well. And then the random forest regressor model had a 0.66 or 0.67, I should say. I decided to also do a feature importance because this was the model I ultimately chose as the best predictor. The feature importance was the highest was longitude, which very much, and I will get into some of the analysis of that later, and then the estimated year built and square footage, bathroom, land area, latitude, rooms, bedroom, and then fireplaces. And unemployment rate was a lot lower than I expected. And then part 2 was clustering prices with k-means. I used the elbow method to determine the amount of clusters to use for the k-means model. I chose 3 clusters based off of the elbow. The price cluster on a DC map, so I did it over a latitude and longitude and then with the prices, and it clustered into 3 distinct sections on the map with few outliers, and it's basically the northwest, the northeast, and then the lower part of DC, which was very much consistent with a lot of the exploration. And then this was the non-clustered map that I did, which was basically just showing the color ranges, which you could kind of see was similar to the clustered, but a little bit less defined. And then I also clustered the land area and price. Had 3 clusters and showed that the land area and price had little correlation, which is interesting from earlier with the idea that the land area overall was very expensive, but I get into that a little later. So phase 3, the execution and interpretation. Model interpretation, part 1. So I used R2 to determine the accuracy of the models in determining DC housing prices, predicting DC housing prices. The R2 is a statistical measurement to see how close the data is fitted to the model's predicted line. The closer to 1, the better the model is at predicting the data. I tried 3 models to determine which model would predict DC housing prices the best. The linear regression model had an R2 of 0.63, random forest regressor model had an R2 of 0.66, and the decision tree model had an R2 of 0.45. Based off the R2, the best model to predict DC housing prices is the random forest regressor model. From this model, the most important features were longitude, estimated year built, bathrooms, square footage of house, and land area and latitude. For model interpretation part 2, I used the k-means clustering to cluster the housing prices in a longitude and latitude map. It showed how the housing prices clustered in relation to the location. The prices had 3 clusters that fell on the map. The map showed their clear clusters showing the northwest, the northeast, and the southern part of DC. Historically, this makes sense because the northwest is the most expensive and desirable place to live in DC, and the southern part of DC is historically more disinvested, and a river separates it from the rest of the city as well, which has an impact. The northeast is a middle ground in terms of prices and desirability. Many places in the northeast are considered up and coming. I then used a map to show the pricing without clustering and with the price ranges being color coded. The clustered map and the non-clustered map had a similar structure in terms of the higher prices in the northwest and the lower prices in the southern quadrants. I also clustered the features price and land area to see if land area played a bigger factor, since previous research showed that DC housing prices were high because DC land is expensive. The graph of this cluster shows there was no strong correlation with prices and land area. This concludes that the location of quadrant are more important than the actual square footage of land. Not all land in DC is equal in terms of price. So final outcomes. To answer some of the research questions that I originally had, which model can predict DC residential housing prices the most accurately? The random forest regressor model predicts the DC residential housing prices the most accurately because it has the highest R-squared. What features are important to predicting DC residential housing prices? From the random forest regressor model, the most important features were longitude, estimated year built, bathrooms, square footage of house, land area, and latitude. Is it really all about location, and what are the most expensive locations? Yes, location is very important to determining price, which is showed in longitude being the most important feature, which shows west to east, which is important in terms of location. Latitude is also an important feature, which determines north or south in DC. Whether you are on the east or the west side of DC seems to determine more about price than north and south, which is in line with the clustered and color-coded maps. The clustering of prices on DC map also showed the disparity in housing prices depending on where the location was on the map. There are other features that are more important than latitude, which shows it's not just about location, but how big your house is, when it was built, and the number of bathrooms. The most expensive locations are northwest quadrant of DC. The most expensive neighborhoods are Massachusetts Avenue Heights, Colorama, Berkeley, Spring Valley, and Georgetown. And in here are some of my references and the link to my repository. And I will quickly also show you my code just to go through a few things. This is the like cleaning phase and of the project. And then this was the normalizing of the prices. And then here is some exploration that I did as well. And here is replacing the unemployment with the wards, or replacing the wards with the unemployment, I should say. And here's a little bit more exploration. And this was the correlation matrix. And then for phase 2, this was me setting up the test and the training. Also setting up the dummy variables. Then this was the decision tree regressor model. This was the linear regression. And then the random forest regressor. And also the features, showing the features. And then this was the part 2 of phase 2, yes. And this was the k-means. So figuring out using the elbow method and using k-means to fit it. And here was the clustering. And then this was the color-coded map. Then I also did it for the land and price here. I also did an extra one that I did not really add because it was not as conclusive, but I did the estimated year built versus price, which was here, and it was not really conclusive, so I didn't add that. And that is all. Thank you very much.